8 minutes ago, the story of 3I/Atlas changed again. Not because the object suddenly turned toward Earth, not because NASA announced an impact risk, not because James Webb found some cinematic alien machine hiding inside the dust. The real reason this story just became bigger is, in some ways, more unsettling than all of that. James Webb has now given astronomers the clearest chemical evidence yet that 3I/Atlas is not just another strange comet passing through our neighborhood. It may be a preserved fragment from a part of galactic history far older than our own solar system, a frozen survivor from an era when the Milky Way was forming stars at a furious pace and the sun did not even exist yet. In other words, this object is not terrifying because it is coming for us. It is terrifying because every new Webb observation makes one fact harder to escape. Something unimaginably ancient just passed through our system, carrying chemistry we do not see in our own comets, and it may be telling us that our solar system is far less typical than we once believed. That is the hook, but the deeper story is even better. When 3I/Atlas was first discovered in July 2025 by the NASA-funded Atlas Survey Telescope in Chile, the object was already moving at an absurd speed, about 137,000 miles per hour, fast enough that astronomers quickly realized it was not gravitationally bound to the sun in the way ordinary solar system comets are. Its path was hyperbolic. Its origin was outside the solar system. And just like that, humanity had only the third known interstellar object ever confirmed passing through our cosmic backyard. The first was Oumuamua in 2017, the second was 2I/Borisov in 2019, and now here was 3I/Atlas, another messenger from somewhere beyond our own stellar neighborhood. That alone would have made it important, but important does not automatically mean extraordinary. At first glance, 3I/Atlas still looked enough like a comet to fit inside the broad expectations astronomers already had. It had an icy nucleus. It developed a coma, that glowing envelope of gas and dust around the core. It brightened as it approached the sun. The early headlines practically wrote themselves. Third interstellar object found. Rare, fast, scientifically valuable, fascinating, but manageable. Then James Webb got involved, and manageable stopped being the right word. The reason Webb matters so much in a story like this is not simply because it sees farther than older telescopes. Webb does something more powerful than taking beautiful pictures. It reads chemistry. It breaks light apart into detailed fingerprints and asks a question normal images cannot answer. What is this thing actually made of? Visible light can show you a bright coma, a fuzzy structure, maybe a tail and some shape. Infrared spectroscopy can tell you what gases are present, how much of them there are, how they are distributed, and what that chemistry implies about the environment in which the object formed. That difference is everything. If you really want to know whether 3I/Atlas is just another icy wanderer or one of the most revealing cosmic visitors ever recorded, you do not start with its silhouette. You start with its spectrum. And what Webb found in that spectrum is exactly why this object is now back at the center of the conversation. In late 2025, after 3I/Atlas had already passed its closest point to the sun and was heading outward again, Webb used its instruments to capture the first mid-infrared chemical fingerprint ever taken from an interstellar object. Right there is a huge moment. Not one of the best, not one of the cleanest, the first. The first time humanity has directly pulled that kind of chemical detail from something that was born around another star and drifted into our system from interstellar space. And almost immediately, the chemistry began to look strange. Webb directly detected methane gas, the first time methane has ever been directly detected on an interstellar visitor. That alone would have made the observation historic. But the real tension is in why that methane mattered so much. Methane is highly volatile. It does not like to sit around exposed to heat. If it is near the surface of a comet approaching the sun, it should sublimate readily. So when Webb detected methane after 3I/Atlas had already been warmed by its solar pass, the implication was not that the methane was casually sitting out in the open. The implication was that it had likely been buried beneath the comet's outer surface, insulated from the sun long enough that only deeper heating released it later. That means 3I/Atlas was not just chemically interesting. It was layered, preserved, built in a way that kept some of its most volatile materials hidden until the right thermal conditions finally reached them. And once that methane emerged, astronomers noticed something else that made the story even harder to shrug off. The methane-to-water ratio looked unusually high, with few clear analogs among the comets we know in our own solar system. That is the first rehook in this entire story. Because if one volatile ratio looks unusual, you can still try to call it an oddball. You can say nature is messy. You can say one comet is weird. But then Webb added another clue. It confirmed that 3I/Atlas was also releasing far more carbon dioxide relative to water than typical solar system comets. Not just a little more, unusually more. Enough that researchers started describing the object as chemically distinct from the overwhelming majority of comets formed around our own sun. Now step back and feel what that means. You are no longer looking at a random frozen traveler that merely happens to have crossed our path. You are looking at an object that seems to preserve a different recipe, a different thermal history, a different formation environment, a different origin story. That is no longer just a comet passing by. That is evidence from another planetary system, and not just another planetary system, but perhaps from a much older chapter of the galaxy than our own. And if that sounds dramatic, the next layer is the one that really changes everything. Webb's near-infrared observations and the later ESA Webb analysis did not just find unusual gas ratios. They found isotope patterns that pushed the case from strange to extraordinary. One of the biggest results was the deuterium level. Deuterium is heavy hydrogen, and in 3I/Atlas it appeared at exceptionally high levels, about 30 times more than what scientists typically see in solar system comets. 30 times. That is not a subtle variation. That is not the kind of difference you bury in a footnote and move on from. That is the kind of number that forces astronomers to ask whether this object formed in an environment so cold, so deeply frozen, and so chemically distinct that the conditions were unlike almost anything preserved in our local comet population. At the same time, the object showed only traces of carbon-13 compared with the lighter carbon-12, another clue that pointed in the same direction. A very old origin, a system that formed much earlier in galactic history, before repeated generations of stars had enriched its environment in the way our own solar system was later enriched. Now the story stops being about a passing comet and becomes a time machine. Because according to the ESA Webb findings, 3I/Atlas may have formed 10 to 12 billion years ago, during what astronomers call cosmic noon, the era when star formation across the universe was near its peak. Think about that for a moment. Our sun formed about 4.5 billion years ago. Earth formed after that. Everything familiar to human existence belongs to a relatively late chapter in the cosmic book compared with the age this object may represent. If the chemistry is being interpreted correctly, then 3I/Atlas could predate our sun by billions of years. It may have spent its earliest existence inside a cold and dense star-forming environment, preserved in deep freeze, then eventually been ejected into interstellar space where it drifted for an incomprehensible span of time before wandering into our solar system. This is why the title works so well when it says James Webb just revealed that 3I/Atlas is older than the solar system. It sounds like clickbait until you realize the science is actually pushing in that direction. And what makes this even more powerful is that 3I/Atlas is not just old in the abstract. It is scientifically useful precisely because it is old and chemically different. Astronomers are not excited simply because they found a cosmic antique. They are excited because the object gives them direct evidence about the environments in which other planetary systems formed, and perhaps more importantly, about how unusual our own system may be. That line matters a lot. We tend to think of our solar system as a normal example because it is the only one we know intimately. But a visitor like 3I/Atlas acts like a control sample from elsewhere. If its chemistry looks radically different, then perhaps the pathway that produced our own comets, our own volatile inventory, and eventually our own habitable planet is not as common as we once hoped. That does not just change comet science. It touches astrobiology, planetary formation, and the question of whether the ingredients that led to life here are widespread or rare. That is the second major rehook, because now the question is no longer just where 3I/Atlas came from. The question becomes what 3I/Atlas says about us. For years, when people imagined interstellar visitors, they tended to gravitate toward the loudest possibilities. Is it artificial? Is it accelerating oddly? Is it a probe? Does it mean aliens? Those questions are emotionally magnetic because they feel like shortcuts to cosmic drama. But 3I/Atlas presents a different kind of drama, one that is quieter and arguably more important. The object's own documented features, its icy nucleus, its coma, its hyperbolic path, its volatile release, all remain broadly consistent with a comet. NASA's fact sheet is explicit that its characteristics, color, speed, and direction, fit what astronomers expect from a comet. And NASA is also explicit that there was never any danger to Earth. At closest approach, the comet stayed about 170 million miles away from us. So if you are hoping for an apocalyptic near-Earth collision story, this is not that. But if you care about whether our understanding of planetary systems in the Milky Way just got a lot more complicated, then this is one of the biggest stories in the sky. Because credible mystery is often more durable than sensational mystery. A fake secret can go viral for a day. A real scientific puzzle can power an entire niche for months. And right now, 3I/Atlas is exactly that kind of puzzle. Every time you think the object has given up its main surprise, another detail pushes the implications wider. First, it was simply the third interstellar object ever observed. Then, it was Webb's first direct mid-infrared chemical fingerprint of such an object. Then it was methane. Then the unusual carbon dioxide abundance. Then the isotope ratios. Then the growing realization that this may be a deeply ancient body from a much earlier galactic era. That is not one hook. That is a ladder of hooks, each one higher than the last. And the higher you climb, the more this object starts to feel less like a stray visitor and more like a witness from another epoch of the Milky Way. This is exactly where a strong script has to slow down and translate the science into something human. Imagine holding a stone older than your house. Easy enough. Then imagine one older than your city. Harder. Older than your civilization. Harder still. Older than the species that would one day discover it. Now keep going. Imagine an object that may have formed billions of years before the sun lit up, frozen in a star-forming cloud so cold and so chemically distinct that the isotopes locked inside it still carry that memory across interstellar space. That is what 3I/Atlas may be. Not just a comet, a preserved chemical memory of a region, a time, and a system we have never seen directly. It is as though the galaxy sent us a sealed sample from one of its oldest laboratories and asked whether we are ready to understand what we are looking at. And that word sample may be more important than people realize, because astronomy often works at a terrible distance. We infer, we model, we compare faint signals from impossibly remote places. But interstellar objects are different. They come to us. Not gently and not often, but when they do, they give astronomers a rare chance to inspect material from beyond the solar system without having to cross light years to get it. That is why every interstellar visitor immediately becomes precious. Oumuamua was weird and frustrating because it arrived fast and left fast, raising as many questions as it answered. 2I/Borisov behaved more recognizably like a comet and gave astronomers a better anchor. Now 3I/Atlas expands the picture again, and what it seems to be showing is that the galaxy may be full of chemically diverse small bodies that formed under conditions very different from our own. If that is true, then every future interstellar object becomes more than an observational curiosity. It becomes a potential test of how normal, or abnormal, our own solar system really is. There is another reason this current angle is stronger than the usual made-up panic. It gives the audience something more satisfying than fear. It gives them escalation through evidence. A weak viral script starts loud and stays loud until the audience gets numb. A strong retention script starts with a shocking promise, then keeps earning the viewer's attention by revealing one concrete layer after another. That is exactly why 3I/Atlas is dominating this niche right now. The topic has everything these channels want: James Webb, urgency, rarity, cosmic scale, and the phrase interstellar object, which instantly opens a curiosity loop in the viewer's head. But the versions that last the longest are the ones that do not just scream impossible over and over. They deliver a chain of increasingly consequential facts. First, this object came from outside the solar system. Then Webb measured its chemistry directly. Then methane showed up. Then carbon dioxide looked unusual. Then deuterium turned out to be wildly elevated. Then the age estimate pushed the object back toward the galaxy's earlier history. Each reveal increases stakes without needing to fabricate a fake signal or a secret NASA cover-up. That is exactly the kind of structure that keeps people watching, because every paragraph promises a bigger payoff than the one before it. That is also why the best version of the hook is not to start by talking about a comet at all. Start by talking about time. Start by telling the audience that humanity may have just analyzed an object carrying chemical memory from before the sun existed. That changes the emotional frame instantly. A comet is familiar. An object older than the sun feels mythic. It feels impossible in the best way. And once the audience is emotionally inside that idea, you can begin the descent into details. The speed, the path, the discovery, the first Webb fingerprint, the methane, the carbon dioxide, the isotope ratios, and the cosmic noon origin story. That is a retention ladder built for a long-form script. Now here is where the story becomes even more fascinating than the headline. Because an object like 3I/Atlas does not merely tell us about one lost system. It tells us about a whole category of hidden diversity the galaxy may be carrying around without us ever noticing. Our solar system taught us one recipe for comet formation: ice, dust, carbon-bearing molecules, volatile behavior shaped by the sun's heat, all preserved in our own frozen outskirts. But that recipe may only be one local version of a much larger galactic cookbook. If 3I/Atlas formed under colder conditions at an earlier era, with different isotopic enrichment and unusual volatile ratios, then it hints that the galaxy may have been manufacturing chemically different small bodies for billions of years before Earth even existed. That means some of the most important differences between planetary systems may not show up first in giant exoplanets or star surveys. They may show up in these tiny frozen migrants that slip between stars for ages and only occasionally flash through the field of a human telescope. That idea should completely change how viewers think about small objects in space. We are used to treating comets as leftovers, as debris, as fragments of formation, rather than central characters. But leftovers are often where history hides best. A finished planet has been melted, reworked, resurfaced, weathered, differentiated, changed. A small, icy body can remain much closer to its original state. It can preserve chemistry like a vault. In that sense, 3I/Atlas may be more historically valuable than many much larger worlds. Not because it is more dramatic to look at, but because it may have remained cold and isolated enough to keep an ancient record intact. And now that record has passed close enough for Webb to read pieces of it. If you stop listening there, the story is already impressive. But you should not get comfortable yet, because there is another layer that makes this discovery even more powerful. Webb did not observe the object at some arbitrary moment. It caught 3I/Atlas after perihelion, after the comet had been warmed by its closest pass to the sun. That timing matters because heat can expose deeper chemistry that was locked away before. In other words, the sun itself became part of the experiment. It warmed the outer layers, triggered volatile release, and helped reveal gases that might otherwise have remained buried and invisible. When methane finally showed up, it was not just a chemical detection. It was evidence that deeper layers had started talking. The object was effectively opening its archive as it left. And that creates one of the best mid-video rehooks in the entire topic. If the first Webb observations already gave us methane, high carbon dioxide, and extraordinary isotope clues, then what else was still trapped deeper down that we never got to sample fully? How much of 3I/Atlas remained chemically hidden even during its pass? What if the most important part of its story was still buried below the layers sunlight had time to reach? Suddenly, the audience is not just looking backward at what Webb already found, they are leaning forward toward what we almost missed. That is a much stronger emotional engine than shallow fear, because it makes the viewer feel the cost of incomplete knowledge. It turns the object into a near-miss archive from the ancient galaxy. That feeling becomes even sharper when you realize how brief this opportunity actually was. Interstellar objects do not park politely in the solar system waiting for us to study them forever. They arrive fast, they cut through our planetary neighborhood, and they leave. 3I/Atlas was visible for only a limited span. It passed inside the orbit of Mars, went behind the sun, resurfaced for observations, and continued its journey outward. NASA noted that when it leaves at the same speed it entered. That detail almost sounds poetic. The sun bends its path, warms its surface, coaxes some chemistry out of hiding, but it does not keep the object. 3I/Atlas came from elsewhere and will return elsewhere. We get one brief look, one chemical interview, one chance to compare our own solar system against a visitor from another stellar past, and then it is gone. This is where a great long-form script should widen from information into consequence. Because once the audience understands what 3I/Atlas may be, the discovery stops feeling isolated. It becomes a preview. If one object can tell us this much, what happens when the fourth interstellar object arrives, or the fifth? What if future surveys begin catching these visitors earlier, while they are still incoming, when space telescopes and ground observatories can coordinate for longer and at more wavelengths? What if the chemistry of future objects turns out to be just as strange, or stranger? What if some resemble 3I/Atlas and confirm that ancient, cold, isotope-rich systems were common in the galaxy's earlier eras? Or what if they look completely different again, proving that our current sample is far too small and the Milky Way is even more chemically diverse than we imagine? That is why 3I/Atlas matters so much. It is not just a discovery, it is a prototype for an entirely new kind of comparative planetary science. And that phrase matters, comparative planetary science, because it is where the real weight of this story lives. Humanity is slowly moving from a phase of astronomy where we simply discover exotic things to a phase where we compare them systematically. Not just one exoplanet, but classes of exoplanets. Not just one comet, but families of comets. Not just one planetary system, but many formation histories across the galaxy. Interstellar objects are one of the most direct bridges between those worlds because they bring foreign material into our reach. They let us test whether the chemistry that shaped our solar system is normal, rare, or only one local variation in a much wider spectrum of outcomes. If 3I/Atlas really formed 10 to 12 billion years ago in a colder and chemically different environment, then it becomes a kind of fossil from the Milky Way's earlier life. And fossils are powerful because they show not just what exists, but what existed before the present world took its current shape. That is what makes this claim so powerful. James Webb revealing that 3I/Atlas may be older than the solar system is not merely a flashy idea. It is a compressed way of saying something much deeper. Humanity may have just decoded the chemistry of an object that formed before the sun, drifted through interstellar space for billions of years, and briefly entered our system carrying clues about how different the galaxy once was. Say that slowly enough, and it no longer feels like a trending topic. It feels like perspective shock. And perspective shock is exactly what the best videos in this niche are built on. The audience does not come only for information. They come for that moment when the scale of a fact becomes emotionally legible, when they stop thinking of the universe as background and start feeling it as structure. When an object turns from a bright dot into a witness, when chemistry turns into history, when a telescope stops being a machine and starts feeling like a time-reading instrument. Webb does that better than almost any scientific instrument alive today. It does not simply look far away, it looks far back. And with 3I/Atlas, it may have looked into a frozen object old enough to carry the chemistry of a galactic era our own solar system never personally experienced. And now we arrive at the most important question in the entire story. What does it mean for humanity if one of the most revealing objects we have ever studied turns out not to be dangerous, not to be artificial, not to be theatrical, but simply older, colder, stranger, and more chemically alien than we expected? I think it means we are entering a new era of cosmic humility, an era where the biggest shocks may not come from monsters, collisions, or science fiction scenarios, but from precise measurements that quietly reveal how provincial our assumptions have been. We thought we understood comets because we knew our own comets. Then an interstellar comet arrived and said, in effect, you know your neighborhood, not the galaxy. That is why I would end this script where the emotional truth is strongest. 3I/Atlas did not stop the world because it threatened Earth. It stopped the world because it forced astronomy to stare at a piece of matter that may have formed billions of years before the sun, preserved its chemistry across interstellar night, and then surrendered just enough of that chemistry to James Webb for us to realize how much we still do not know. It carried methane from buried layers. It released carbon dioxide in unusual abundance. It held isotope signatures unlike the comets that shaped our own sense of normal. It may have formed during cosmic noon, inside a cold and dense environment long gone, then wandered through the Milky Way until at last it crossed the path of a civilization capable of reading its light. And maybe that is the most haunting part of all. This object was ancient, long before Earth had oceans, ancient before the first cell, ancient before the dinosaurs, before mammals, before humans, before language, before telescopes, before the idea of astronomy itself. It traveled through darkness longer than any civilization has existed, and yet in the smallest slice of time, in one brief pass through our solar system, we happen to be here with the right instrument pointed at the right place. That is the kind of coincidence that feels less like timing and more like revelation, not because the universe intended it, but because sometimes reality is already overwhelming enough without invention. Sometimes the truth is that a frozen visitor from another star system can arrive carrying the memory of a galaxy older than the sun, And we only notice how extraordinary that is once we break its light apart and really listen. So the next time someone says 3I/Atlas is just another comet, remember what James Webb actually found. Remember the methane, remember the carbon dioxide, remember the deuterium, remember the carbon-13 deficit. Remember the possibility that this object formed 10 to 12 billion years ago and spent almost all of that history far beyond our system. Remember that there was never any danger to Earth, but there was absolutely danger to one very comforting illusion, the illusion that our solar system is a standard template for the rest of the galaxy. 3I/Atlas may be telling us something else entirely, that the universe has been experimenting for much longer and in many stranger ways than our local evidence ever allowed us to see. And if stories like this are the kind that make the night sky feel bigger after you hear them, stay close, because the next interstellar visitor may not just confirm what 3I/Atlas hinted at. It may go even further. It may arrive earlier, brighter, closer to our instruments, with an even deeper chemical archive waiting to be read. But right now, this is the signal that matters. Not a radio signal, not a secret transmission, a chemical signal written in methane, carbon dioxide, heavy hydrogen, and ancient ice. A message from a time before the sun, finally decoded by a mirror hanging a million miles from Earth. And once you understand that, 3I/Atlas stops looking like a passing object and starts looking like one of the oldest stories ever told to our species.